So thanks everybody for making it to the third and final day of this introductory workshop for AG2PI. Congratulations on making it this far. There's a lot of information thrown at you all yesterday. And today we're going to discuss how to use Rstudio and R on CyVerse. So we'll be using the same container or application rather on CyVerse Vice on the discovery environment. And we'll start off this morning where Tyson will walk you through the user interface of Rstudio and kind of just explain the different features that are available in Rstudio. And then he'll get into some of the introductory material about the R programming language itself. We go over some variable types, how to do just use R as a calculator, which is nice when you're sort of thinking about experiments. You can just open Rstudio and do a little bit of the back of the envelope calculation once you learn how to do that today. And then I will have a break, and then I will take over, and we'll go through how to subset data, which I think is kind of one of the things that R is best at doing. It's what I really like R for. It's really great at cleaning up data. So you get some messy data sets from some people, and you need to pull out the information that's relevant for your study. And then in the afternoon, after our break, I'll walk you through a data set that's actually phenomics data from the TerraRef project with sorghum bicolor data. And we're going to walk through how to do the sort of data subsetting, how to do some of the plotting with Ggplot too. And I'll walk you through how to make publication quality figures or start to get in the direction where you might start to see when we're plotting these things with Ggplot too, that some of these figures, or at least the style of figures, will look familiar from scientific journals. So with that, I will take any questions that anybody has. Oh, one last thing before questions. We're also going to, because I got a lot of questions about using commands and iRods, we're going to take the figures and tables that we make in the afternoon, and we're going to send them to a folder on the data store together as an exercise, just so that everybody can sort of walk through how do we get data into the Rstudio container, how do we make figures with that, how do we get some basic summary statistics on our data, and then write out our figure and our summary statistics to the data store. So with that, I'll take any questions. And if there are no questions, then I will turn it over to Tyson.
Yeah, I think actually, let's hold off on the questions because I'm going to walk through starting up the Rstudio again, and then I'm going to have to wait a minute for my Vice instance to be available. So then we can maybe do the questions while we're waiting for our Vice instances to wake up.
Sounds good.
Okay, so you guys can see my screen. So today we're going to be on this very last section on the bottom of the website, this introducing R and Rstudio. And so if we click on this, take a second to load. Takes 10 seconds to load. You guys can see me, right? I'm not frozen. So we know the internet's working.
Yep, I can see you.
I can see you.
It's interesting that it's so slow.
It's Friday.
Yeah, okay. Well, we'll let that load for a second. So as you recall, you can go to your de.cyverse.org, or you go to the user.cyverse.org, and then that brings you to the discovery environment. So go ahead and log into the discovery environment. So once you're logged in, you can click on your apps.
Can I, if I have that window open from yesterday, because
So-
mine is still thinking about it, will that work?
You're still running your same RStudio instance from yesterday with
Yes.
the AG2PI workshop folder in the imports folder.
Yes.
Yeah, that's perfect.
Okay.
Okay, so for me, I'm going to come to AG2PI. And then I'm going to click on RStudio. I'm going to leave the analysis name the same. I'm going to add the input folder using the community data. We'll scroll down to the AG2PI workshop. And so I should see the AG2PI folder is selected. So now in my input folder, it should say AG2PI. I'm going to leave my resource requirements blank, and I'm going to launch my analysis. Okay, so as we do this, it's submitting our jobs to the CyVerse orchestration platform. So maybe not at this point. Does anyone have any comments about the time that you guys spent yesterday working in the terminal on the command line using, I believe we were using the bash shell. Or any questions about that?
No.
Okay. So the website is finally loaded for me. So if you get lost or you fall behind, you can come to this last section. There's some instructions here. So we've just clicked through to this quick launch, and we've launched the RStudio environment. So while we're waiting for that to get started, the R programming language has been around for about 20 years now, I think, maybe a little bit longer than that. The RStudio graphic user interface has only been around for about 10 years, I believe. So the RStudio group started creating RStudio as a way to interface with the R programming language. So you can go to their website, and you'll see that they're an independent group that are releasing this open source software, which they call RStudio. They also have proprietary licenses to RStudio. So if you want to use RStudio Pro, you can pay them for that. They have platforms like Shiny, which is a web-based application some of you might be familiar with. And so RStudio is a program that's written in a combination of Java and C. So it's actually not even written in R, but it's a graphic user interface that can be run locally on your laptop. So that's probably how most of you have used RStudio in the past. You've downloaded it from the RStudio group, and you've run it on your laptop. What we're doing in CyVerse is running a almost identical platform called Rstudio Server. And so the Rstudio Server is RStudio, but it's designed to run inside your browser. And so our RStudios look just like regular RStudio that you run on your computer, but it's in the browser. There's some benefits to this. So we're running things in CyVerse, and by running it in CyVerse, we're connected on Internet 2, which is the research internet for the US, and it's very fast. It's far faster than your home ISP. It may be faster than the internet that your institution has. And so with that Internet 2 inside of CyVerse, we're able to move large quantities of data around. So we'll come back here. So we're still waiting for our RStudio to spin up, at least I am. Just maybe with a quick show of hands, how many of you have used RStudio Server in the past? So you can give us a little thumbs up if you've used RStudio Server. Okay, I'm seeing one thumb. So how many of you, let's do thumbs up now. How many of you have used RStudio in the past? Give me a thumbs up if you've used RStudio. Yeah, as I recall from Tuesday, about half of us have used the RStudio before. And so Rstudio Server is literally the same interface. All the tools are the same. It's just running on someone else's computer, not on your laptop. And so what we're going to do in a minute, once my application is available, is I'm going to walk through the different parts of the UI. And then I'm going to talk about how we can begin to use Rstudio on the internet, moving our files into it, and starting to get toward what we call reproducible research. So at this point, my Rstudio started. So I'm going to start going through the walkthrough of the UI. It's not critical if your Rstudio instances are not available yet. So you'll get a chance to walk through on your own. Let's see. So my Rstudio is now available. So we can see it's running on a URL inside of CyVerse. The very first thing I see on the left side is the console. So this console is running the R language. And I think we're kind of familiar with this at this point. Yesterday, you guys ran everything in this second tab called the terminal. This terminal is running the bash programming shell. So this is a different language. This is the basic, I'm talking to a computer language. And then this is specific to the R programming language. R echoes out that it's version 3.3 or 3.6.3. So we know which version of R we're running. And you can see it's giving us some options here if we want to learn more about R. There's a third tab here, which is newer to Rstudio. This just came out within the last year or so. And this is the Jobs tab. And the way the Jobs tab works is you start a local job by selecting an R script. So we can create files that have the .r extension on them. And we're going to do that in just a moment. And we can create these jobs and run them essentially as background processes. So when you run a script in the console, it essentially locks the Rstudio. So if you do something here, you're in the console, there's a chance that your entire Rstudio may become non-responsive because it's using all the threads on the computer to do the thing that you've asked it to do. By using the Jobs tab, you're able to run things as background processes, which will leave your Rstudio available to you to continue working in it. I really enjoy using the Jobs tab for running Shiny apps. So I can start a Shiny app as a background process. It will open a new browser tab in my browser. And I can go to the Shiny app and do the things in the Shiny app and come back to my Rstudio and continue working. So that's one of the powerful uses of the Jobs tab. So on the left side here, we have this Jobs tab. If we go to the little icon above it with the plus and a white piece of paper, you can see here that this is the Create Something New button. And so we can create a new R script, our notebook, and our Markdown, a Shiny app, and a lot of other options here. Just basic text files, C++ files, Python scripts, etc. And so right now, if you click on the R script, you'll see that it adds a new browser tab. So we've just dropped the console terminal Jobs tab down. We now have this open unsaved file that's sitting here. And so this is a blank R script that we have not yet saved to our computer, but it's now available for us to begin editing in it. And for the most part, I would say it's a better practice for you to write your R code in a little script window like this than it is to just work directly in the console. So if you're working directly in the console, the work that you're doing might go away and disappear. If you scroll up for it, you can go look for it again, but you won't see it necessarily. So by keeping it here, you can find it and you can rerun it by using these little buttons here in the upper part of the R script page. So you can actually run an individual line. You can run a previous line, or you can run the whole code block. On the upper right, we can see there's another pane that has the environment windows selected first. And so this is where things that we load into R, and we're going to spend some time talking about creating objects in R in a little bit. But when you load things into the R programming environment, it'll show up here. So you can have your objects here, and these could be things like data frames or individual factors or variables. There's a second tab, which is really important, which is often overlooked, and that's the history tab. So whenever you run something in the console, it will show up here in the history tab. And this is really useful to go back and look at the things that maybe you ran only in the console and you didn't save in your R script. The third tab here is this connections tab, which we'll wait to talk about. But when you're running your R scripts, you'll begin to see more and more options appear up here in this section. So as new tabs come in, you can start to use them more. In the lower right, we can see that the Files tab is open. And so this Files tab goes into the home folder where the RStudio user exists. For our CyVerse containers that we're running, we know that from our day yesterday that we have the /home/RStudio user, and that's where this is right now. You can click on these three dots over here on the right, and you can change the home directory if you need to. But for right now, we're in the home. Inside of this input folder is the AG2PI workshop, which I asked CyVerse to add when I launched this. And so you can see as I navigate into the input folder, into the AG2PI workshop, that it begins to propagate the folder paths here so I can see those. The plots tab is empty. Ryan's going to go through that later today with you guys as you begin to use the different plotting packages in R. But your plots can show up here. Because we're running in Rstudio Server, you can often pop these plots out as new browser tabs on your computer. This third button, packages, is pretty useful. So this list of packages here are all of the packages that are currently installed in our Rstudio Server environment. So if you were to install an Rstudio base on CyVerse and run it, it would not have all of these. We are running the Rstudio Verse container from the Rocker group, which has installed already all of the tidyverse. And so with the tidyverse comes all of these packages. To wait for these things to install could take probably an hour or more. So it's great to be able to start our Rstudio environment and have all the tidyverse packages ready to go. If we want to install more packages, we can click on the install button. It'll ask us which our repository we want to look for our packages in, and then you can search for the packages and install them. We're going to do this on the console line in just a few minutes, but you can install using the graphic interface here. You can do updates for all your packages to make sure everything's up to date. And there you go. The next tab over is the help button. We're going to do some help features in just a little bit, but this help feature shows all the different help that are in RStudio. So if I type in Ggplot, let's see if this will come up. Actually, we'll do this. I'm too far in the topic. Let's go here. So if I search for Ggplot, it searches all the different features of Ggplot, which are installed in this specific Rstudio server. And so this is a good way to explore all the different features of all the different packages and libraries that you're looking to use. Last, we have this viewer, which is another way to interact with interactive plots. Okay, so I've gone through these 4 panes just now. On the very top line up here, we have a file option, so you can do the same new file. You can start a new project. R has a concept of projects, which are useful because they will load your environment with the appropriate variables and often set the working directory for you. And so you can create a new project. And when you go to create a new project, it'll ask you if you want to put it into a new directory, an existing directory, or if you want to use version control. So we're not going to have time to go through all of the in and out of Git, but the really powerful thing here is that you can use Rstudio to pull a Git repository down from the GitHub or from a GitLab, and then you can work in your R project using version control. So if I were to start a new project from a Git URL, it would bring that project into my Rstudio environment. And then when I'm done working, I can use a new Git connection feature up here. We'll see a new window here that would say Git, and I would be able to submit my changes to my existing Git repository. In the edit code, there's standard features. code view. I'm going to run through these quickly. The session button is pretty useful, particularly when you have done something that you don't like and you don't want it to keep running. It's stuck in a loop. You can terminate R, interrupt the R process, and you can even restart it. So there's some nice features there. You can rebuild your environment and then set your profile. And then last, here's this tools feature, which is basically, these are re-showing us the same features that are in the UI, but they're available here in the drop-down tabs. And then similarly with the help features. I'm gonna pause for a minute. Does anyone have any questions about the RStudio UI or any comments that I haven't mentioned? Is there anything that people really like about RStudio? Anything you really dislike? Yeah, I would say that I really enjoy RStudio, partly because I came to RStudio having first learned R only in the command line. We had a UI available to us about 15 years ago called the R Commander, which I used, and I didn't like it that much. It used to be that you would load things into your data frame in R, and I would never know what was loaded because I would forget what I put in there. So just having that environment window in the RStudio is one of my favorite things, being able to see all the different things that are loaded in memory that I can access. So in R, I'm going to move this up a little bit. Actually, I'll go ahead and do this. I'll show two examples here where, okay, we have a good question from Serge. So when I say install packages, where do they go? Are they on the computer or on the server? So RStudio installs packages onto the computer that it's running on. So if you're running RStudio on your laptop, it installs those packages into a directory on your computer where all of the other R libraries are installed. Because we're running Rstudio Server, it's going to install those packages onto the virtual machine into this running container that we're running. And so in CyVerse, when you run a container, you're running this image that we've pre-created for you, this tidyverse image. So any installations that you do in this running instance, when you cancel this job or you save and complete it and you go and you start RStudio version 3.6.3 again, none of those changes that you made are going to be saved. So you will have installed things, you'll have changed things, but our image on CyVerse is basically immutable to you. And so we would have to do an update to our image for the next time you run that container. So just as a quick example of running in the R console, I'm gonna use R as a calculator. So let's see if I can make this a little bit bigger. And maybe the other instructors, let me know if this is big enough or not big enough for you guys to read. So I'm gonna use the control button, or on if you're on a Windows laptop, it's a control button. You press Control and the L button, and that clears the console for me. And so if I type in the number 2 and I just enter, R returns this thing that says, okay, you just said 2. If I press 2 plus 2, I'm using this now as a calculator, and it returns the number 4. If I do 2 space plus 2, and I do it again, it still returns the number 4. So I had those spaces in there, and it's still okay. You might recall that when you were working on the command line yesterday, spaces in Bash can be volatile. If you have a space, that often means that you're moving into a new part of the statement. So if I try to do some math here, where if I just say 2 and a space and a plus, and I do a carriage return, it shows me a plus again. So it's waiting for me to give it something else. So this is an incomplete statement. And then if I go ahead and add one more 1, we can get it to work again. So R can go and do basic mathematical calculations. If I want to do some multiplication or some division, it'll return these numbers for me. If I do a really large number, it'll return the number with a significant figure on there. So that's the basic output for R. Let's see. We have a little exercise here. So what is the output for 5E3? So if we type in 5, an E, a lowercase e, and a 3, what is the output going to be? Does anyone know? Can I get the answer in the chat? Great. Okay, so if I type in 5E3, we can see that it's giving us the significant figures behind the 3. Okay, so 5 to 3 zeros. So it's a nice way to shorten up showing a number. Okay, second quick exercise. I'll put this into the chat. Okay, so how would you add 5 and 3 and multiply that sum by 2? So just how would you calculate something on a single line? There we go. So if I do 5 plus 3 divided by 2, or multiplied by 2, let's see what happens here. 5 plus 3 times 2 equals 11. What about 5 plus 3 times 2? 16. So the priority of the operators, so plus, minus, divide, multiply, or exponential. So the calculations have different priorities. And so the multiplication has a higher priority than the plus. And so if you put that next to 2 numbers, it does that first, and then it does the plus. And it's the same. I think the order, maybe Meg or Ryan can remind me. I believe it goes, is it multiplication, division, subtraction, addition? I'm not sure what the priority order is for R, but you want to be very careful about how you set your numbers together. And when you go to do your math, often you can mess this up, particularly if you're trying to calculate a function. Okay, so we've just been doing basic addition, subtraction, multiplication, but R can do things with other conditional factors. So you have, in basic mathematics, we've got integers, we have floats or numbers that have decimal points in them, we have complex numbers, and then we also have strings. So if we wanted to write something as an alphanumeric or an alphabet, like a character, and then we also have logical operators. Oh, thank you, Meg. Oh, good, and Ryan's given us these good things to remember. So R can take 2 numbers and tell us whether or not it's true or false. So if I say 1 is identical to 1, it returns this function true. So I've asked R to tell me whether or not 1 is in fact 1. So if I say 1 is equal to 2, it's false, right? So those are not the same things. If I say 1 is less than 2, it returns true. If I say 1 is greater than 2, it returns false. So here R is using a logical condition for establishing whether or not two things are true or not. And again, I'm doing all this directly in the console. If I do this here in my unsaved R script, I can say 1 is less than 2. So in order to do this, I can run the line. And so if I run that line, it takes that number I just put into the file and it's run it on the terminal. So what I've done now is I've kept that little mathematical operator safe in my R script. I can add comments by using the #. This is a comment. And if I try to run the comment, nothing happens on the line. So you can see I say run and it just does a return. Okay, so I can comment my work by adding the # and then doing the thing right after it. So one way that we can help ourselves along is to use the help feature. So help is available here, but we can also look for help here on the console. So if I say help and I do actually let's see if it auto completes help. Yeah, so as I type in the console, RStudio starts giving me suggestions about what I might mean by what I just typed. And so in this case, the very first one that comes up is help. And so I can see that it's showing me the manual or the help manual for the function help. If I press the tab to autocomplete, so Ryan and Meg talked about their deep love for autocompletion, and I share that love. But if I press tab, it'll show me that help. And if I press it again, R will add the parentheses. And so these parentheses are super useful because whenever you want to do something, you have to make sure that that parentheses closes. And so here, RStudio automatically completes the parentheses for me. Or excuse me, am I saying that right? Is it parentheses or is it a curly brace or a brace? Okay, so if I just type in the word plot, it just took the word plot, which is a thing in R, and it's changed the help menu here to show me the R documentation for plotting. If I type in help Ggplot, which is I think something, oh, is it Ggplot 2? Ooh. I shouldn't have presumed so much. Nope, it hates me. All right, I'm gonna cancel that. Oh, I see. So when Cora types in plot, she got quotations. And so the quotations are something that R likes to use to specify things. It's if you don't use the quotes, it's often going to go and look for something in your environment. It presumes it's something that's part of the R environment. And it's not necessary always to use the quotations, but if it adds it, it doesn't change anything if you didn't use it. So there was a question about where things go when we want to install them. And so if we're using a new R environment and we haven't installed anything in it yet, we might need to install something. And so let me go ahead and clear up my R script here. So I'm going to add a comment. I'm going to say installation of new packages. And then on the next line, I'm going to type in install.packages. And you can see now that RStudio is being nice and it's trying to tell me, oh, is this what you mean? And I can select that. And then it brings up the help menu here. So to install packages, it wants to look for a package or library. And then there are these other optional flags for setting the repository, where to get the package. So the CRAN repository is the main repository where most R packages live. but many programmers write their packages and don't put them on CRAN. So they might be on the GitHub, or they might be in other repositories that you can get off of the internet. But by default, the RStudio is going to be looking for packages in CRAN. And so that's the same thing here. If I come to packages and I go to install, you can see that the default repository is CRAN. And now if I click on the repository option, you can see it shows us more help menus directly from R. Let's see. Megaran, do you guys have a package that you think we should try to install? I think we already have Ggplot installed. No suggestions? Okay, let's look at some of these. Okay, so Ryan suggests HMISC. Cora, if you said Gplot, I think what we were looking for was Ggplot, which is the name of the package, or even more specifically, I think it's Ggplot 2. Meg says feet map. Okay, so let's try feet map. So I've added the quotations here. And so that when I want to install just a single package, I can just say the name of that package. And let's see what happens. I'm going to hold down the shift button and return to run that line. Nothing happened. Maybe it's a control button. There we go. Control and enter will run it. Oh, okay. So notice actually, I don't think Meg meant to capitalize that. I think Zoom auto capitalized that. So this was case sensitive. So I'm going to get rid of the capital P. I'm going to run this again. So in the console, we see that it's installing packages and it's hit the R library. It's found the package. It says it's installing it from source, and it's done it. It's actually succeeded in this installation. RStudio uses red text here, which for those of us that work a little bit more on the command line, the red is not often a good sign, but it looks like I've just installed this P heat map or feet map. Never used this before, so I don't know what it's actually called. Pretty heat maps. Okay, so we can see that the P heat map is now inside the packages on this machine. Ryan suggested we install this HMISC. So if I say install.packages HMISC, it'll maybe try to install the HMISC. But I want to show another option here where if we want to install more than one package, we can use this letter C, which is the concatenate feature. So let me delete this. So if I type in C and then I add the left-hand side parentheses, it auto completes the parentheses for me. So I'm gonna go ahead and try to reinstall the P heat map. Actually, let's see. Can I delete the P heat map from here? Let's try to delete it. Yes, let's uninstall P heat map. So I've just uninstalled P heat map, and it ran the remove packages line here for me. But we're going to reinstall it again. So I'll say P heat map, and then I'm going to do a comma and another quotation, and then HMISC. So by concatenating these two together, it might install them. So let's hold down Control and then run the line. Okay, now R says one or more packages will be updated. Restarting R is strongly recommended. So I'm going to go ahead and let R restart itself right now because I don't have anything else loaded in this environment. The restart is going to take less than a second. It's not going to interrupt anything inside of CyVerse. It shouldn't turn off the VM. So you can see there, it's just restarted R. It's looking for P heat map. Oh, it looks HMISC is intended to be capitalized. So we had an error there. So I'll recapitalize HMISC and I'll run this again. Okay, so you can see that mranmicrosoft.com is actually probably another repository than CRAN, but something installed, something else is installing. And now we can start to see that this compiler is running and it's installing these different things. So Christine asks, the new packages that you install in your list every time we run CyVerse in Studio, or RStudio in CyVerse. So every time you run a new RStudio container in CyVerse, it will not have any changes to it. So pheatmap and hmisc will not be installed in this RStudio tinyverse the next time I run this. If we wanted to create a new tool in CyVerse or with an updated container, we could. We can update new tools so that they have all of your specific lab groups tools in them, and that would be your new tool. So yeah, every time we run the program, or every time we run RStudio again, it runs from the image that we're hosting. So it's this unchanged image. So you run the same image fresh every time, and then you bring in your script that we're writing here, and you do your package installations. And once you've done that, you have the new things that have just changed. So this installation for hmisc and heatmap, they're still going. So they just finished. It took almost a minute or two to install these. That's not terrible. But there's sometimes when you're going to try to install things and it could take hours to build those new applications. And that's when you might consider integrating a new RStudio in CyVerse, or using a different container that has your tools already in it. Okay, there's another option here when I do an installation of packages that I can add another statement, which is to add the dependencies. So I'll do the concatenated the two of them, and then I'm going to say dependencies. And now RStudio is asking me, do you mean dependencies? And I'm going to say true. And so by doing this, the package installation will look at my R environment, and it'll see if anything else is relied upon, if hmisc needs other packages. Like I thought I saw it installed the JPEG package, but if I run this again, it's going to go through and look to see if those missing packages are there. So let me scroll up real quick. Okay, so I've run this line here. This thing is still running down below where we can't see, but by adding in the dependencies, it's installing these other things. And I think some people have mentioned dependency hell. And so the problem with other people's software is that they build it on other software. So it's this giant stack of blocks held up by a little penny at the bottom. And this package relies on like 20 other packages. So by telling it dependencies equals true, RStudio is going to go out for us and find all those other packages and make sure that all the correct versions are installed to run these two things. And this is great. This is package management for us. So it's going to take care of all the things for us, and we're going to get a working piece of software at the end of this. Okay. So this is going to be installing for a second. Ryan, we're going to go over on time for talking about data structures, but I can try to close it out in the next few minutes, or maybe we can, I don't know when we want to go to break, if we want to go to break now or in 12 minutes, see how far I can get.
Feel free to keep going, Tyson. We could skip over the loading data since I'm going to go over that this afternoon.
Okay. Okay, so I'm still waiting for my packages to install. Does anyone have any other questions about this process of installing packages? And you can see that the console is running here, but I'm still able to interact with my unsaved R script here. Okay, Shu asks, what is the benefit to save the running environments after finishing a script run? So you would want to save your environment if you were building an R project. So if you had some scripts that you'd written and you'd set a working directory, which we actually haven't done explicitly right now, having that saved would make it easier the next time you started this project over from scratch, that you could start the proj file, it would set the working directory, and you would be ready to restart whatever the code was that you'd written the last time. Okay, so I see this thing right here. It says unable to set a connection to R. This is probably my internet blinking on me for a minute. Because everything's running in CyVerse, I'm not worried. My browser connection may have just broken. And let me just double check. Am I the only one talking? Can people hear me?
Yes.
Okay, good. So
Yes.
my connection to that Rstudio server may have just been interrupted somehow by my local internet service provider. But whatever R was doing inside of CyVerse, it should still be doing it. And it might be that the reason why this hasn't reloaded again is because R is still installing those packages. So sometimes when you run something in the console, it's now running in the foreground. Rstudio is stuck while it's running that thing. So I'm suspecting that my Rstudio right now is actually still compiling all those dependencies for those two packages. And that's why it's not responsive right here. So we can hope that it'll become responsive again in just a minute. Let me go to our notes here. So I spent a lot of time talking about the UI, how to use the help, how to install packages. We're getting close to talking about how to load data. Okay, so we've gone through the structure of our basic calculations. We're going to skip this loading data because you're going to do it ad nauseum with Ryan this afternoon. So let me get into this discussion about data structures in R. So I mentioned before that there are these different objects in R. Everything in R is an object. So you can have things like characters. So you can assign a value to a character, just like in algebra. So I can have A equal a number. The number could be an integer. The number could be a double or a float or something that has a decimal point behind it. It could be a complex number. So you can create these characters that exist in the environment. They could also just be a string. It could be a name. So the character is one thing. A simple character is just a string. And you can set that as a character. You can set numerics, so things that are numbers. And they can even have decimal points attached to them. An integer is a whole number only, so it can't be divided into a double. And then we have these logicals that we saw. So you can set things as true or false. So we have a couple of exercises here where you can type in str for string, and then you can add in the number 10, and then you can do it with a quote, and then you can see what returns. I think I'm still waiting for my, oh, it's back. Woohoo! So after that package installation finished, it looks like Rstudio responded, and I'm back into my environment. Couple of points. I'm going to do a quick save here. So this is this untitled.r script. Here I'm in the home folder. We have an input folder that we have that imported the workshop material. I am going to, let's see, I'm going to do a new folder. I'll call it output. And then I'm going to select the output folder. And then under this more tab, I have set as working directory. So if I select this in the R console, it just said, oh, you know what it didn't, because we're still outside of it. It didn't like that I was checked. I have to go into this. So when I set the working directory, because this home was set here, it set the working directory as the slash or the ~/ which is the home directory. If I go into the output folder and I set the working directory, it then sets the working directory as the ~/ output. So I've just set the working directory as this new folder I've created. Now I'm going to come over here to this untitled and I'm going to save it. Notice that it's already set me inside of this output folder. So I'm just going to say example1.r, and then I'm going to save that file. So now you can see that this example1.r file pops up here. Okay, so as we write our R scripts, we can keep all of our stuff in the same line. Let's see, Wellison asks, is there any tutorial guide on creating private personalized apps in CyVerse? Oh, there are many of them. So those are all on our learning.cyverse.org site. Okay, Christine asks how to get to the output folder again. So here in the files pane in the lower right, you start out in the home folder. I selected the new folder, which is to create a new folder option, and I created a new folder and I named it output. And when I did that, the output folder was now visible here underneath input and Kitematic. To set that folder as my working directory, I had to select that folder, which brought me into the folder. I then used graphically the gear icon that says more, and I set the working directory. So if I go back to the home folder, I go into the input folder, the AG2PI workshop folder, we'll go into this ag data folder. So now I'm up inside of this third level folder. If I click on the gear button and I say go to working directory, it brings me back to the current working directory, which is still output. And so any changes I make in the working directory should show up here. Okay, so I'm going to try typing in some data structures into my R script here to see what happens. So if I say as dot character, and I just try to run that line, it shows character 0. If I put in a number there, it shows me as character is quotation mark 1. If I do an A, it says object A is not found. If I say A equals 1, and I run that, I've just created an object in my environment with the value A and 1. And then if I say as character, it shows me the number 1 as a string. If I say as dot numeric A, and I run that, it shows me the number 1. So the use of these quotation marks indicates to me that as a character that A equals 1 is a string. But if I convert that as a numeric, it shows me A as a number. I can do the similar thing as I make as integer. Yeah, thank you, Stephen. So control enter at the end of the line will make it run. So as integer returns the same thing. So let's make A 1.2. So if I run control enter on A equals 1.2, then I say as character, it shows me 1.2 as a string. As I run it as numeric, it shows me 1.2 there. If I try to say 1.2 as an integer, it rounds it back down to 1. So what if I try to make 1.2 1.6? So I rerun the A value as 1.6. I run it as an integer and it still makes it back to 1. Okay, we can also do this as a factor. And so as a factor, it shows me these levels. And so factors have levels. See if I just jumped too far ahead there. I think we're doing okay. Okay, so doing things as numerics, as integers, or as factors returns these different features of this value in my global environment. So if I try to do something as a string, so if we say string the number 10, it says that the string 10 is a number. If I say string quotation marks 10, it returns the string number 10 as a character. So this is another feature of R that's been developed over the last 20 years, but you can run things as strings or as characters or as numbers. So what happens if we try to run? Let's see. So we've gone through this step of creating A as a number, so it can be as an integer like the number 10. So I'm going to rerun this as the number 10. So now that we've got this value A, and it's the number 10, if I create a piece of multiplication, so if I say A times 2, I can run this and it does the math for me. So this is like basic algebra. So I've assigned the value 10 to this feature A. So when I ran the install packages, we used the concatenate feature. We can concatenate values into a single object. So if I come here, let's see, there's how to build a device app. Okay, good. So if I say X, so R has a feature in it, and I cannot remember what it's called. What is, Ryan, what does the caret dash mean? It's like a directional arrow, but I can't remember what they call that. So
I don't remember what the name is, but it's generally good practice to use that to assign things to variables.
Right.
Sometimes if you use, even though equal sign will work, the more advanced your R programming gets, sometimes it can break in the middle. So it's best to, if you're going to create a variable, like in the example that Tyson is typing out, where he's creating a concatenation, he's creating a vector that's concatenating all of those numbers together.
So yeah, the caret dash essentially looks like an arrow pointed to something, right? So we're creating something and we're assigning it to that vector. And as Ryan said, in R, using the equal sign is not always the best way to do that. An assignment operator, as Meg calls it. So as we assign this concatenated list of numbers, 1, 2, 3, 4, 5, to the value X, it shows up in our global environment. So we've just added this thing X using the concatenate feature for the numbers 1, 2, 3, 4, 5. We can do this another way. We'll make a new one called Y, and I do the assignment operator, and then I say 1, 5. So what this should do is create a list of numbers from 1 to 5. Okay, this is interesting. So X was created as a number, and then Y was just created as an integer. So 1, 2, 3, 4, 5 comes in as a vector as an integer. The third way that we can do this is to use the sequence. So we'll do Z now. Z assign the seek. Oh wow, very, very informative. So seek just shows up as 3 dots. 1 to 5 by ones. So I can leave these spaces in here, I can take them out, but what sequence is saying is give me a number sequence from 1 to 5 by units of 1. And I run it. And so now I see again, it's a number from 1 to 5. So if I try to do the sequence differently, so let's say it's 1 to 10 and units of 2, we can see that it goes from 1 to 10. Actually, it only goes from 1 to 9 because it's increasing from 1 to 10 in units of 2. So we try this as a 0. Let's see how this goes. There we go. We got 6 numbers there. So from 1 to 10 in units of 2, or do this as units of 3. Okay. So you can create number sequence in that way by setting the frequency at which you're setting the numbers up. Okay. So what happens if we try to add a character? Well, actually, let's do this thing where we're going to add 2 different vectors together. So let's create a new one called. Actually, we've got A already. So let's create a new one called D. Assign in a concatenated order. We still have A up here, and then the number 2. So what does that do? So D now is A and then that second number. If I say D is actually A and X, we can see now that it's the A, 10, and then X, which is 1 through 5. So we're concatenating 2 vectors together. Let's do one more option here. Let's make a new one called E. Assign the concatenation of D, which is this 10, 1, 2, 3, 4, 5, and then the string A. Okay, so A is no longer our vector. A is a string. So and maybe I can make, so maybe this makes a little bit more sense. We'll just make this the letter W. So if I make that the letter W, so this string W is not this vector. So what it's done is it's taken our numbers, which we created, and it's turned them into characters. So by including a string, it turned all of our numbers into characters. So what R is doing is it's reducing the value of that object that you've created down to a string because it can understand a string. So if you have characters and numbers, or characters and complex numbers, or characters and floating numbers, and you put them together, R is like, what are these things? And it reduces them down to these atomic vectors, which once you've done that, you're kind of screwed. Like you've taken your data set and kind of wrecked it. The best example I can give you of this is a data set that you have that has no data values, which are assigned as things like NaN, not a number. So if you have a string, not a number, inside of a list of numbers, and R reads those in, it can accidentally convert all of your values into characters. And then you're in deep doo-doo. I'm going to take a break. We're way over on time. You guys have been going for an hour now. So let's stop for, let's say, 12 minutes. I've got 10:08. How about we come back at 10:20?
Feel free to ask any questions in the chat or unmute your microphone. All right, so I started recording again, and like Tyson said, so we went through a lot of the nuances of how the R programming language works, and feel free to go back, watch the video, read through the documentation. At the very end, I have some links to place, at the very end of this page, I have some links to places on the web where you can search for specific questions, like Stack Overflow and Medium. And I'll go over that at the very end of the workshop. But I'm going to start sharing my screen, and we'll get into, I think this is probably what R is most powerful at doing. And this is managing what you could think of as like an Excel spreadsheet. And this is kind of what I love about programming in R. I started off exactly like where everyone is here, showing up to a workshop and getting a little bit of an introduction in this. And then it was just a lot of playing around, bugging postdocs in my graduate school lab to help me debug my R code, talking to other coworkers, and eventually it got to the point where I could just work on my own. So hopefully this helps you start you on your journey towards that sort of independence. So let me share my screen. All right, so I'm gonna start off with a blank R script, and we are going to talk about matrices and data frames. So if by chance you've taken something like linear algebra, you might have been introduced to the concept of a matrix in there. And this is kind of what R operates as. So matrices and data frames are very similar. So if you want to look up the difference between them on your own, that would definitely help. And we're going to start off with a very simple data frame example. So I'm going to call this data frame hello. And I'll use the assign with the arrow. I'll call this data.frame is the function. And then we'll say 1 through 26 letters. And then the words equal to hey and you. So I run this. Now I have this data frame called hello, and you see that it says there are 26 OBS or objects of 3 variables. One of the really nice features of RStudio that I particularly like is when you have small data sets, you can click in this global environment on the data, and you can visualize everything that we created in the data frame. So if we go back to this data frame function, we can see that what this data frame is it's the numbers 1 through 26, which are in the first column. Think of this is like pretty analogous to using like Microsoft Excel or some other, or Google Sheets when you're using this view. And then we look again here, and there's this letters. So what this did was it took every letter and filled it in A, B, C, D all the way to the end. So we did numbers 1 through 26. There's 26 letters in the English language. And then it repeated the words hey and you every other time. So there's 13 heys and 13 yous. And so we have one data frame. This is our little toy example. We'll get into some actual data analysis this afternoon. So this is just to introduce the concepts of data frame, making little toy examples and going over some of the mechanics of how data frames work in R. So if we create another data frame called hi, and we do the same input, letters, we concatenate with hey and you. We call that one hi. Let's close this. We look at that. It's called hi. It's named, it looks exactly the same, but it has a different variable name in this data column. And so what we can do with this is we can take these variables called hi and hello, and we can combine them with the data frame function. This is just one way of doing this. If you search on Google for how to combine data frames in R, there's a bunch of different ways to do this, depending on what you need. So if you think about when you're working on your own on this, it's best to ask the question, how am I combining it? And what do I need to combine? And so if we look at the output of this, we can see the dimensions have changed, right? So there's the same number of rows. There's 26 rows, 26 objects, and 6 variables. So 3 plus 3 is 6. And then if we look at howdy, it's combined it by the columns. So the columns are, it's being joined by the columns together. And so if you use this data.frame function to combine 2 data frames, it will combine them by the columns when you enter it this way. So when you're working with your own data and say you have 2 different data sets, say one person's working on one part of the project, one person's working on another part of the project, it's like a time series data, best to divide the work, right? Because time series take a while to collect. So you might want to combine it by rows. So when you are searching on Google for how to combine it, you can think, how do I combine 2 data frames in R by rows? And there's a bunch of different approaches to doing that. So we can try doing this a different way. So if we wanted to combine this by rows, we could say, let's call this, just say df, and we'll say we want to do r bind or row bind, and we'll say hello and hi. And then it'll say error, names do not match previous names. So one of the interesting things about when you're trying to do row binds in R is you need to have an understanding of what your column names are. So if we ask this with the call names function, what the column names of hello are, we see that these are the names. That is okay. And then we take a look at call names of hi. And we see that these don't match up. So in hi, it named this last column C ... hey ... u ... So we can use these functions to fix our column name problems. And so what we could do is say we have the column names of hi, and since we know that these are the same dimensions, we have the same number of columns, the same kind of data, we just want them to join by rows, we can actually use the column names function to assign these column names to this data frame's column names. So there's different ways, there's a whole bunch of different ways that you can rename your column names. This is probably the fastest for us to join them by rows. So now, if we take a look at the column names of hi, you see that it's the same as when we run the column names of hello. So now, if we were to rerun this, I'll just type it out again. F rbind, hello, hi. Now we don't get the error because the column names are the same. So now when we go back and we look at df, we see that it's joined it in such a way where when we go down to the 26th row, 1, 2, 3, there we go, you see that it starts over, and it's joined our data frames by the rows instead of by the columns. So if that was what we wanted, we've gotten there. If you wanted to do this same function without using this, or this same method of joining the data frames without using this data frame function, there is a complementary cbind or column bind, and say hello and hi. And we'll call this df2. Now, what do you think? Do you think that this will let us combine them now that our column names are the same? So it did. So R sometimes makes decisions for us because as the user, we're telling it, hey, I would like you to join these columns together. So if we go into this df2 and look at the column names, see that these are all the same. So we have these repeated column names. One way that we can look through these different aspects of a data frame is through something called indexing. And so we can use indexing with vectors. So like Tyson introduced numeric vectors before the break. We can also use it with data frames. So with a data frame like df2, we use these square brackets, and then there's a comma. And on the right-hand side of the comma, this would be our column name. And on the left-hand side of the comma, where my cursor is, right here, that would be our row number. So if we wanted to look at column 3 of data frame 2, hit enter, it will tell us that these are all of the lines in column 3 of data frame 2. These are all the rows. So if we added a number here, this is telling it very specifically that we want the value in the data frame that is at the position of row 2 and column 3. So if I run this now, you can see that this returns just you. And you see that there's this levels thing here. And so what exactly does the levels mean? So if we take a look at data frame 2, we can use this thing called class, the class function. This will tell us that data frame 2 is a data frame. Right, so this is good for checking when you're running a bunch of functions to check and make sure that you're getting the output that you want. But if we decide to use the indexing and say we're going to run it on column 3, this is going to tell us the class of column 3 in the data frame. And it's saying that it's a factor. So this is like a statistical factor. So the levels are referring to the fact that there are only two possible values in that column, hey or you. And so when Tyson was running through the different as dot whatever, let's say that you don't actually want a factor, and that you want column 3 of this data frame to actually be characters. So this is an interesting use case where you could say as character data frame 2 column 3, and it will print it out, and you see the levels are gone. But if we rerun the class function on data frame 2 column 3, it still says factor. So in order to change the class of a column inside of a data frame, or the class of any variable that we have in R, we need to store it somewhere. So if we wanted to go back up here and say we would actually want this to be a character, we'd have to store it back in the column 3 of the data frame itself. So you see that runs. I don't see any output. I'm not printing anything to the R console. And now if we run class on that column one more time, it says that the class is now changed to a character. So this is kind of an interesting way of, when you get error messages, sometimes R will say that your characters need to be factors, or cannot do this operation on a factor. It only works with characters. So knowing how to diagnose that by indexing and then doing these changes is like a really, really useful thing in R. Some other useful functions for diagnosing your data frames, getting information about them, would be like dim, D-I-M. This will tell us the dimensions of data frame 2. So this will tell us how many, first number will be how many rows, and then the second number will be how many columns. So if I run that again on, say, the data frame high, you can see that down here in the console that high has 3 columns and 26 rows. Or if we run it again on just df, you can see that it has 52 rows and 3 columns. There's also the summary function, which will tell you the statistical summary for numerical values. It will give you sort of basic quartile statistics. So it'll give you the minimum value, the first quartile, the median, the mean, the third quartile, and the maximum values for numerical values or integers. And then it will count the characters, the character values. And for this value here, it will say, hey appears 26 times and you appears 26 times. You see down here it says other. It's truncating the print to make this fit in this space. So the other would be the last letters of the alphabet after the letter F. So if you do the mental math and you go through that, you'll find that there are 20 letters left. It's only printing the first 6, and they all appear 2 times. So 20 letters left times 2 is 40. So summary can be really great if you have a bunch of numerical data in your data set and you just want to get like a really quick view of it. So a little bit of a callback to the shell exercise. We also have head and tail in this as well. So we can do the head of data frame, or df, and it will print by default the first 6 rows. So by default, head will print out the first 6 rows, and tail will print out the last 6 rows. So what if we wanted to just print out the last few rows? So if we use the tab complete inside of a function in R, it will start to tell us what we can do with it. And so X is an object. So this right here is actually X equals the data frame. And then the next argument is N, which is a single integer. So that would be the number of rows. So if we want the last 2, we just put the number 2 here. And it'll print the last 2 lines. So great connection between the shell and R, slightly different syntax, functionally the same thing. And there's, in the read the docs, there are other functions for checking the different data types. So the view will open up our tab, which we got to before by using this data aspect of the global environment and clicking. So you can also invoke that inside of the script itself in Rstudio. There's another function called class. So if we run class on data frame, that will tell us the class of data frame. I think I already went over that. And then there's str, which tells us that there are, the first line will print out, so str will print out the dimensions. It will tell us that this is a data frame. It has 52 rows, and there are 3 variables, and then we can find out what the different classes are inside of a data frame with the str function. There'll be a few other functions that we'll go over this afternoon that are also really useful for taking a look at your data to see what exactly you have. There's also the length function. So length will tell us how many columns there are in a data frame. So it's a little counterintuitive. So let's try this again, but we'll make a vector 1, 2, 3, 4, 5. I'll just call this X. So now if we try running length on X, we get 5. So this is a little interesting idiosyncrasy of how data frames work in R. So each row itself is treated as a vector. So that is, it's like the data frame are a bunch of vectors stacked on top of each other. So you can also, if you didn't want to, say you wanted to know how many rows there were in the data frame without running the dimension, you just wanted that single value. You want to make sure that, say, your join worked correctly. You can run n row, which is the number of rows, and it'll just return the single value of the number of rows. Do the same thing for columns. Single value. And we put those together with the dimension function. So let's go into a little bit of data manipulation. So this would be the data manipulation section and the read the docs under exploring data. So I have a cat, so let's make a data frame about cats. And we'll call this column coat. And we'll say calico, black, and tabby. We'll say that we're going to look at the weights of the cat. And we'll say these are in pounds, maybe kilograms, since we're, my conversion between pounds and kilograms in my head is not so good. I think a 3.2 kilogram cat would be a rather large cat, 5 kilogram one. And then we'll say likes string, the underscore. So remember the variable names, it's the same as the shell. So we'll say 1 means yes, 0 means no. So if we have this all together, you can see when you move your cursor by the parentheses, it'll show you where it closes. And see, I made an error up here. So it's telling me that this parentheses is actually closing this concatenation statement. So I forgot the parentheses up here. Now I see that this is being highlighted. That's closed. This is closed. This one is closed. This one, it closes the data frame function, and then this one is extra. So another useful feature of Rstudio, and I like doing this before I run something, is just sort of run through and make sure that all of my different closing elements of a function are lining up where they're supposed to. And so it'll highlight that. So let's make this cat's data frame. All right, so we've got our data frame, the 3 cats, calico that likes the string, the black cat that does not like playing with strings, and the tabby that does like playing with strings. And so we can do some manipulation with this, but first let's check the different classes or the class of cats. So this is a data frame. Let's check it with str cats. So you can see that coat is being treated as a factor with 3 levels. Weight is numeric, and the string is numeric. So we can also do additions with this. So one way of manipulating your data frames is, say you underweighed by 2, and you wanted a short way of doing it. You don't remember which column number it is. You can use the $, and then all of the column names will pop up in Rstudio. We can select weight with tab complete. And then we can add 2 to all of the weights. And it'll return all of those values with 2 added to them. And so again, this isn't storing this back in the data frame. This is just looking at those values that it's calling. It's calling the column and adding 2 to it. And so we can also take a look at what happens when we add coat and coat. So we know these are factors. So let's see what happens. We get warning, addition is not meaningful for factors. So it returns NA, NA, NA for the value. So this is a good, R will generally tell you when you make an error, like what the reason is. And a lot of the times, if you are searching online for why you're getting an error, can copy and paste this into Google and then get rid of the thing that's specific for your problem. And more often than not, somebody will have already asked the question about how to change something, or you'll be able to read something on a blog or Stack Overflow or another place and find out exactly what the problem is. And so we can also do some subsetting, and this is, it's okay in base R. I'm not gonna pretend that it's awesome. The base R way of subsetting things is a little confusing, and this afternoon we'll go through some of the tidyverse packages. So those are already installed in this container, so we won't have to install those. And they make it a little bit easier because you can start to ask the packages to do things with specific column names. And so this gets a little weird. So we'll just go over the classic R way before lunch. And then after lunch, we'll walk through a good example where we load in some data and we start subsetting it, plotting it. We'll do some exploratory data analysis this afternoon. And I think it'll make a little more sense when we're working with actual data instead of just doing these toy examples. So if we wanted to subset our cats by cats who are less than or equal to 3 of our cat weight units, and we store those in P. So check what P is with class. P is a data frame, right? So when you use subset, it's going to create a data frame. And if we type in P and hit enter, or rather control enter or command enter, depending on if you're on a Windows computer or Mac respectively, it will say that the only row that it could find, or rather the only cat whose weight was less than or equal to 3 was the calico. Met a lot of tiny calicos in my life, so that makes a lot of sense. And so there's another way we can do this without the subset function. And I find myself, when I do base R subsetting, I often use this method myself. And I don't know why. I think it's just because it's stuck in my head after graduate school. So you see that this is similar to what we did when we were looking at just the row and column, right? But in this case, we can actually invoke a logical statement in here, say cats weight, and then do the same thing, less than or equal to 3, and put the comma here. And so what this is going to do is we're telling R that we want to use logical indexing to extract the rows from our data frame that meet this condition. So we'll get the same answer when we store it in Q. So we'll look at the class of Q just to make sure. Okay, that's still a data frame. And then we'll look at Q itself. And so we got the same answer. So sometimes when I'm working with data sets, this is a quick way of looking for rows that meet a certain criteria. I don't regularly use subset. It might work for what you're doing if it sticks in your mind and you're like, okay, like I got to use the subset command where I put the data frame first and then the logical conditional, and then I need the output. You can also do the same thing with indexing. You can get really fancy with the indexing and do multiple logical statements. You can make these super complex, and you can do a whole bunch of different things with it. And so we can also ask things like cats like string equal double equals as a logical, and it'll say equals to 1. And it'll tell us, based on all of the rows in the column name like string, which ones of those are equal to 1. So it'll say true, false, true. So we remember when we look at our cats data frame, say this would be true, this would be false, and this would be true. You can do the same thing with the logical indexing, but the syntax will be different. So let's try it with cats like string double equals true. So that is automatically going to take our 1 or 0 and evaluate that as 1 being true and 0 being false. And so it's automatically selected the calico row and the tabby row. So these are going to give us 2 different answers. So this is a good illustration of how the logical subsetting with the comma for the rows. But just for the sake of an example, let's try doing this where we say we forgot that we were working with rows and we put the syntax like this with the comma first. Let's just see what happens. So now it prints out everything. It didn't actually evaluate which cat liked the string or not. It just looked at, is the column cat, or is the column like string there? And then added the coat to the like string. It's weird behavior. So sometimes it's good to, if you see this, print out, stop, think about it. Is this what I want for my subset before moving to the next step? So when I am cleaning up data, and I'll wrap up with this and then we'll take our hour break. When I'm cleaning up data, I like doing this in a sort of stepwise fashion where we'll go through this process after lunch or whatever hour-long break you're taking, where we go and we add the data set, it becomes a data frame, and then we do these sort of checks along the way and do logical subsetting until we get to our answer. And there's a whole, like once you figure out how to get the data into this format, there are a whole bunch of different things that we can do with it. And with that, I think we'll take our hour break and be back at 1 after the hour. And I will stick around for a bit and take any questions that people might have. And I will stop sharing my screen and pause the video. And I will share my screen. So first thing I want to do is, so since some people were following along this morning with Tyson, let's just use what is R's version of PWD, which is getWD. Okay, and so mine is printing that I am in my home under the user. And so we can change that. And this will be important for when I'm live coding the other section. We can change that to, you want to use the double quotes for the directory paths when you're setting this in R, we'll just set it to the relative path to my home directory. Okay. And then if we type in get wd, we'll see that I am in my home directory as the RStudio user. So if your first get wd command shows different attributes, that's fine. We just want to run this command right here, this set wd with the double quotes. So that's just this symbol. We're not putting this in twice. And this will set your working directory so that you can follow along. And then if you're in the same container with the AG2PI workshop data, that is also helpful. If not, please just follow along. And I'll go through how we're going to load the data. So again, set wd, double quotes, tilde, / to set it to your relative path. Use the relative path to set it to your home directory. So the first thing we're going to do in any analysis is load some libraries. So we do this with the library command. So we installed packages this morning with Tyson. So if we want to load a library, also happens to be in double quotes. Or rather, not in double quotes. I think that's a typo. I'll fix that in the documentation. So no double quotes around the library name. So we're going to load the library Ggplot2. And we're going to load the library plier. So I'll type comments as I go, just so that it's easier to follow along. So we're loading libraries. When I write analysis scripts for analyzing my data, I leave lots of comments in as I'm writing the code, because if I stop, say, to do something like this, to teach a workshop for a week, it's easier for me to come back to my code next week and figure out where I left off. So it's pretty important to leave comments in your code. Also, if you're working with other people, it really helps for the readability. So now let's add another comment. Load the data set. This is the pound sign at the beginning for the comment. And so we're going to call this data set Mac season 6. And we will assign it with our little arrow. And we'll use the read table function. And so this first argument is the file. And so this will be the path, the relative path of the file. And we can use tab complete here. So we go input / AG2PI workshop, ag data, and then we're going to use this season 6 cleaned.txt. So once you get the first directory in there, you should be able to just use the arrow keys. Sorry, you should be able to just use the arrow keys to select this. So this is kind of running off the screen. So what we can do is put a comma here, hit enter, and RStudio will automatically move this onto a new line, makes it a little readable. And so we can say that the separation, or sep, is equal to this which stands for tab. So this is tab delineated data. Remember this from the shell exercise. We're talking about delimiters. We're using the cut command. R takes similar arguments. And we're going to say header equals true. And then if you remember when we made the data frames this morning before the break, we had character strings that were being loaded as factors. So a good practice when you're working with the data can be to type in strings as factors equals false. So it will import your data as a data frame and not create factors, so that you can go back in later and change them to factors. So this is, we are running R 3.6, version 3.6 in here. This right here, the strings as factors equals false. In the new R 4.0, this is the default value with read table. And if we want to look at default values of a function, we can run help read.table in the console. It'll bring up the read.table, tell you right here that it's in the R utils, or the default R functions. And it will tell you in here the default values. So by default, it's not saying a header, which the header is indicating the column names. It does not indicate a separation delimiter. And it has a whole bunch of other values in here. And then if we scroll down, and it says strings as factors, the default in R 3.6 is strings as factors equals true. And that's changed in R 4.0. So that's something worth noting. And so if we run this with our relative path, and let me just make this wider so that you all can see this, and then I'll be constantly moving this window size. So as we're plotting, we can look at the plots, and then we can see all of the code as I'm writing it. So this is probably about as wide as I would write code in R. So if I do Control Enter or Command Enter, if you're Command Enter on a Mac, Control Enter on a PC, this will load the data set into our R environment. So instead of us creating a data frame from some variables that we've made up, we've now created a data frame with the read table function by importing this file, this tab delimited file, into our R environment. So it'll show up over here in the environment tab. And so we can see that this is a really big file compared to what we were creating before. There's over 33,000 rows of data in here. And so that's a lot of data. And one thing that we might want to do when we look at the data for the first time is to take this function from dplyr called glimpse, which is similar to some of the ones we learned before the break, but this is in the dplyr library, and this will let us take a look at some of the attributes of our season 6, Max season 6 data frame. And so this will tell us all of the different variables. So this will say we have date in here. You've got cultivar, which is like a gene line of sorghum. We've got the canopy height in centimeters, the day of year that the measurement was taken, and it has all of these different values, right? So this is saying that canopy height is an integer. So we're not going to have any decimals with that. It's rounded to the nearest whole number. Same with day of year. So that is being treated as an integer. And so this dBl, or double, is going to be a decimal value. So we're going to have decimal values for our temperature minimum, our temperature maximum, the mean temperature of the day that it was collected. This is GDD, or growing degree days. I see that Mandeep got an error. Let's take a quick look. Okay, let's see. Cannot open the connection. No such file or directory. So there's an underscore. You used an underscore for the ag data, and it was actually just a dash. So that's where the tab complete really helps, is when you're dealing with long paths, the like this. So this is the error. It happened right here. So this should be a dash instead of an underscore. So as you're typing the location of the file, if you hit tab, it will start being able to get all the way there. So just give me a thumbs up if everybody is able to load the data set, and I'll stop here, and then we can glimpse the data, or I can go through the glimpse one more time before we move on to the next part. Okay. Yeah, I agree with Meg. So the typos are super hard to diagnose, because the human brain tends to fill in things and skip over characters. Like, unlike a computer, the computer is very literal. It'll go all the way from the beginning to the end. And when you're looking at a path, you might not notice at first that it's an underscore or a dash, like when you're going back and forth. I will show the tab complete one more time. So we go here. Let's delete this all the way to my home directory. So if I push tab, this pops up, and I can use the up key and the down key to select the folder. So I'm going to select input by just scrolling with the up and down arrows, and then hit tab. And then the next folder hierarchy will pop up, and I can then so it's I'm seeing some typos for the errors for opening this. So start with your relative path here with the tilde, put the slash in, and then hit tab, and then select input and hit tab, and then the next folder will show up. And then ag-data will show up. And then we can select the season 6 cleaned. So I'll paste the full path in the chat. So that should be the correct full path for this file. Okay, has everybody made it to this? Does everybody have this data set imported as a data frame? Raise your hand if you're still having trouble with this. And you need somebody to help. Okay. So we can glimpse the values of our data frame. And so we see that we at the bottom, because the console's shrunk, it'll show the last line of the glimpse. You can see these are LGLs or logicals. So there's logical statements. Oh, there was a water deficit treatments during this season. Maybe not. And then there was precipitation on that day, cumulative precipitation over the course of the study, vapor pressure deficit or VPD, mean values. And so we're looking at all of this data. And so some of the phenotyping, the only phenotype that we have in here is the canopy height. Everything else is an environmental variable that's we assume is having an effect on canopy height. So let's say we want to take a look at how does the canopy height change relative to growing degree days. So we can plot data. And so now we're going to use the function Ggplot, which is from the Ggplot2 library. In here, we're going to specify our data set with the argument data. I'm just going to say Mac season 6. You can see this keeps popping up, letting me know, Rstudio is letting me know that I can tab complete. And if you were not able to use the function glimpse before getting to this part, check to make sure that you've loaded the library dplyr. And I apologize that in the documentation it has the library being loaded with double quotes. There should be no quotes around the library names. And so with this ggplot function from ggplot2, we need to specify part of the plot mapping. And so the plot mapping is going to tell ggplot our aesthetic, which is AES, and the aesthetic is where we specify our variables. We're going to say the x variable, this is the x-axis, is going to be growing degree days, or GDD, and our y value is going to be canopy height. And then ggplot2 does some interesting things. So it looks like at face value that this would run. And then I find that I had a typo in here. Okay, so let's fix that. Let's run that. And so I get this empty plot. So what it did, what ggplot2 or the ggplot function is doing is with the aesthetic and the data, the mapping, it's creating the grid to plot the data onto based on the values that you provide with it. And we'll play around as we go through this with changing some of the aesthetics, changing some of the titles and things like that. So this is a really awesome package that I've grown to be quite fond of over the years. I used to do everything in base R plots and understood way too much about the strange syntax of plotting in there. And this is so much easier to get very high quality plots very quickly once you start to play around with Ggplot 2 a bit. So, but we don't have any data here. And so that is because we didn't specify the GEOM or geometry. And so this is going to, I type GEOM in, and there's a whole bunch of different kinds of plots that you can do inside of Ggplot 2. Like any possible plot that you could think of, you could probably make it with this. If not, there's probably a library that extends Ggplot 2 to do what you'd like to do. And so let's just try this with points. So this points, the geom points is going to now point, singular, geom point. It's going to make a plot with a scatter plot where it shows all of the 33,000 data points for the canopy height of this sorghum bicolor data set. So this is showing us from 0 growing degree days all the way to the end. And so this is accumulation of solar energy over time. And so this should look like logistic growth with the plants. They're going to be small for a while, and then they're going to grow, and then they're going to hit a maximum. And so we can kind of see right now that there's maybe some outliers in this data set. But this isn't really informative. So this isn't a particularly informative plot. This is taking all of our data set, which we know by the cultivars variable that there's some genetic diversity in our data set. And we're not really accounting for that in this plot. This is just looking at all of those different genotypes of sorghum as a whole. So let's try doing another plot that's similar to this, but let's try mapping some aesthetics inside of the GUM point. Just give me a thumbs up if you were able to get this image. And if you're having trouble, please raise your hand, and then maybe one of the helpers can help you out. A lot of the times it's like some typos, kind of making it difficult to visualize stuff. It happens all the time when I code, and I'll go back and be like, why isn't this working? Oh, I forgot a closing parentheses, or oh, I mislabeled one of the variables. So it happens all the time. Don't worry about it too much. So just pause here for a second. Now let's make a more informative plot. So I wrote this tutorial from scratch from data that I had, and I came across a funny little thing when I was doing the plots, which I'll go over. So this is a really important thing. Otherwise, you're just going to see all of the labels and none of the data. So I'll write this all out again. Ggplot. We'll say the data are equal to Mac season 6 with tab complete. tab complete is awesome. And then we'll do x is equal to growing degree days. This aggressive tab complete is one of the reasons why I really like doing R code in RStudio and other languages as well. So we can do canopy height. Unfortunately, it doesn't work with the variables in your variable names or the column names in your data frame. But it's better than writing it out in the sort of base R longhand. And so we can actually, so we have this mapping here, right? So this is exactly the same as our first line in the other plot. And I like putting a tab in the new line as well. It kind of helps with the readability. You don't have to. It's just nice to read it. And so we can go back to this geometric point. And so you see we have the mapping value here. We were able to add this to the points. And so when we do this, what we're going to do is we're going to map our aesthetic, and we're going to say that that aesthetic is the color, and then we're going to assign that to the cultivar variable. And then this is really important, otherwise you will get a giant legend of just the cultivar names and not this wonderful rainbow scatter plot. So we say show legend equals false. So by default, when you choose a variable to use to color, it will automatically add in those values in the legend. And we'll see that later when we go down and we subset some of this data using dplyr. So this is all part of Ggplot and dplyr are all part of tidyverse, which is the container that we're operating off of on CyVerse. So this has all of this installed by default. And tidyverse is a whole like little ecosystem within R. It's to do data cleaning and data visualization, and has recently expanded into like machine learning and modeling. So it all uses the same sort of syntax. So once you start to learn how dplyr and ggplot work, and then if you're interested in another package that is part of the tidyverse ecosystem within R, the syntax is going to be the same. And you can actually do really cool things when you're a little more experienced with it, where you can start stringing together different bits of tidyverse. And we'll do a little bit of that towards the end. And so what this plot will do now that we've changed this aesthetic is it will take a little bit to plot, and it will color all of our points by the cultivar, the genetic cultivar here. And so this is slightly more informative than before. But like I said, it's really hard to fit like a legend on here. And let's just say that we know that we want to create a subset of this. We don't want all of the data. We don't want to have all of the cultivars. Let's say we have a few that we're interested in. Because we went out in the field and we know that these hypothetical 3 cultivars of sorghum are our favorites from the experiment, and we're curious about how those values look because we've been going out in the field with everybody and we're interested in selecting variables from the data frame. And so this is going to be with dplyers select. So if you're following along on the read the docs, I have the library dplyer invocation here in the documentation. But if you've already called library, you don't have to, the library dplyer, you don't have to call it again. If you call it again, nothing will happen. It'll just return a blank blank command in the prompt. So like I have it loaded already. So if I ran it again, dplyr, nothing happens. It's already loaded into the R environment. And so let's create a subset of our data with select. So select is from dplyr. And you see that it has this dot data. So we don't have to fill the data in, like explicitly say data equals. The dot means that it's a hidden argument inside of R. And so we can just say Mac season 6. And now we can just list off our variables that we're interested in. We'll say day of year, growing degree days, cultivar, canopy height. So now we have this subset, and let me just back up a second. So in the read the docs documentation, I also changed the Y or the X variable from GDD to day of year. So the plots are very similar, but if you're following along with the documentation, I apologize that I used growing degree days here and not day of year. If you're following along and you want following along with read the docs, this is exactly the same. We're just changing the mapping to the aesthetic, the first aesthetic, day of year equals canopy height. Equals aesthetic, color equals cultivar, show dot legend equals false. So this is the plot from the docs. This is the plot I made on the fly. So we'll just take a quick look at this. You can see the spread on the points is a little bit nicer when we use the day of year versus the growing degree days. And if you're familiar with growing degree days and day of year, well, cumulative growing degree days, they're collinear with each other. They'll be very, very similar, have a similar relationship with canopy height as we plotted over time. So now let's return to our subset. So we have our subset, season 6 subset, and let's take a look. So we have our season 6 subset, and let's use glimpse one more time. I'll take this. So we're interested in the things we observed in the field. Now let's see if we've gotten our subset narrow enough so that we can visualize what we saw when we were walking through the field. So now we see we have less data. So there's less columns. So we have day of year, growing degree days, cumulative growing degree days, the cultivar names, and the canopy heights for all of the cultivars. So how do we narrow this down even further? So we've subset this to get rid of all of the other, we're not concerned about vapor pressure deficit, sorghum's a grass, it doesn't matter as much, it's not a tree. And so let's take a look at how we might do that. So we can use those vectors that we learned this morning. So we'll call those season 6 favorites. And let's select, feel free to copy and paste this from the read the docs. I'm going to type it out really slowly so everybody can follow along because these cultivar names are not intuitive. So I will type this out. PI 569148. That's our first favorite. And then the next one would be PI 585961. And then the last one that we would like to look for is PI 196583. Okay. So I'll give everybody a chance to catch up to this, and I'll just write a comment in here. So say, these are our cultivars of interest. Look at the subset of data. Subset are 6 data with select from dplyr. Okay. So I'm going to just do Control Enter so that we have the season 6 favorites. And then the easiest way to check if we have correctly entered in these values is to do a little bit of filtering with dplyr. And so we're going to call this season 6 figure data. And we're going to say Mac season 6 and then we're going to use the dplyr or tidyverse pipe. So the reason this doesn't look the same as the pipe that we use, yeah, the tab will not work for the cultivar names because they're not in the global R environment. They're inside of the data frame. So if it's too onerous or difficult to type out the names, you can copy and paste it from read the docs, that first line. I'll also put it in the chat just so that people don't have problems with typos. So yes, I'm getting to that, Mandeep. So this is the tidyverse pipe. So what this is allowing us to do is to do the same thing like we would do in the command line, where we pass the output from one function to another without storing it in an intermediate variable. And the reason why we can't use this symbol is that R is a statistical programming language, and that has meaning in statistics. So this would be more like the probability of A given B if we're using this vertical pipe. So the tidyverse ecosystem uses this percent greater than percent as its pipe as a workaround because of the statistical meaning of the vertical pipe that we would use in the shell. But functionally, it's the same. And so we're going to put a pipe and at the end here. Another quick, there is a shortcut for creating the pipe. So it's on a PC, it's Control-Shift-M, and on a Mac, it's Command-Shift-M, and that will just automatically create the pipe for you. It took me a long time to find the shortcut. I had been writing it out by hand for a number of years until somebody said, hey, you don't have to do that. So the pipe will then go to the filter function from dplyr, where we can say that we want to filter the variable cultivar by our, this is a double equal sign, season 6 favorites. And then we'll add another pipe. And then we will use the select function like we used before to create this initial subset. But this time, we're telling it that we want to take this, the whole Mac season 6 data set, put it through the filter where we sort by our cultivar, which is equal to these 3 that we've selected as our favorites. And then we want to select the variables day of year, growing degree days, or GDD, cultivar, and canopy heights. So when we're using the pipes, the tab complete becomes available. So the pipes allow us to start to be able to tab complete with the select. Because it's recognizing that we're going to be using our data frame for those functions. So it's already started to load it into the memory. And so this is something that tripped me up for a while. I didn't quite understand this. So this chunk right here is just doing the thing. And so if I were to run this without this part right here, where I'm using this operator to store it as season 6 figure data, it would just print out the data frame into the console, and I wouldn't have it saved anywhere. I wouldn't have it saved in the R environment. So if we move here to, in my console, this is, or in my script, this is line 128. It could be a different line in yours, but if we move here to this line and hit Command Enter, it's important to hit Command or Control Enter where you're storing it, because if you hit it here, the command will run from here down. It'll go filter, select, and then it won't actually do the creation of this new subsetted data frame. So we're going to execute it from here. You can also hold down the Shift key and select all of the text, just as like a mental check to make sure that you have everything. So Mandeep asks, what would be the difference of using pipe versus not using pipe in this code? So if I eliminated all of the pipes, I can do that right now, and we'll just show you what happens. So if I select all of this, what's going to happen is R will just read this first line, and it will, so if you look at my console here, I'll try and make this a little bit bigger. You see right here, it successfully executed assigning the data frame Mac season 6 to this variable season 6 figure data. And then I got errors after that. So what this did, because I don't have the pipes in there, this just simply copied the Mac season 6 variable to a new variable called season 6 figure data. And then it didn't use any of the dplyr cleanup functions for selecting. So what the pipes allow us to do is to take advantage of using these functions in dplyr to send our input data set on a journey through these different functions. We'll go sending it through. Okay, now right here at this point after the first pipe, we're filtering it by the vector. And then it's taking, now that we've filtered that, we have this new temporary data set. And that's piping it into the select function where it's only selecting those variables. And then it takes this whole block, it runs through all of these operations and then stores it in the season 6 figure data. I hope that answers the question. So now if I rerun this with the pipes, yeah, that's another good point, Tyson. So you can also think of these as and then statements. So technically it's a pipe, but if you think about it, that symbol is saying do this, and then this, and then this. And you can string together a whole bunch of different functions to do things, and you can make it very complex. But this is our example right now. And so I'll run this. And now we have our subsetted data, and we're at 10 to the hour. So we're coming up to our 10-minute break. So let's take a break right now. And I will be right back. And the other helpers will be here to answer any questions that you might have. And then when we get back to this, we'll go through making figures, writing out the files, and then moving them into the CyVerse data store. And we'll kind of wrap up today, and we'll see if there's any other questions you might have. So I'm going to stop sharing my screen and pause the video. All right, I'll start recording again. And just to reiterate, the Ggplot exercise will be put in the CyVerse discovery environment data store under the AG2PI _workshop folder in the community data. So that'll be in the main folder. So you'll have access to the script that I'm writing while we're analyzing this with all my comments when we're after this workshop series is over. So I'm going to start sharing my screen again. And we'll move on to plotting the subset data. So let me scroll down. So at the break, we left off with the filtering the data by our cultivars of interest with dplyr. So now that we have this smaller subset, let's try making a nice looking plot. Let's make a nicer plot of day of year versus canopy heights. And so we can do this now that we don't have 234 different cultivars, we can change our aesthetics in our Ggplot to make it so that we can visualize these and have a legend on the side. And so we can type Ggplot data equals the season 6 figure data, and then the mapping to the aesthetic where X is equal to the day of year, Y is equal to canopy underscore height, and then we'll say by cultivar. Okay, and we'll add a plus at the end there. So putting all these spaces in between the argument, the equal sign, and the values, that's you could add spaces or take them away, just like Tyson said this morning. R doesn't care as much as Bash. When I'm writing a lot of R code, I'll often use spaces because it makes it a little more readable for somebody else. It's a little bit cleaner. So somebody can more easily see what you're doing. So you're not just sort of writing in season 6 figure data without data equals season 6 figure data, so that if somebody is a new user, and eventually you'll not be a new user, if somebody's a new user and they're reading your code, then it makes a little more sense. It's a little bit easier for them to kind of read your code, copy a little bit of it, see what you're doing, and then try it out. And so now I added the plus sign at the end of this line right here. And see this right here. There's this unexpected end of document warning. Point. And that goes away when I add this argument right here. So over here, you'll get some warnings that show up. So if I comment this out, the warning will come back. Say unexpected end of document. That's because I have this plus here and nothing there, nothing after it. So it's expecting something else to happen because I'm telling it to do Ggplot things in a particular order. This little red and white X will pop up. It'll also pop up if you forget parentheses. Let's say unmatched opening bracket. So it's another cool feature of Rstudio is that it'll tell you when you are missing things, and you just hover over it and it'll say what is happening. So unexpected end of document because I don't have the scatter plots. And so we can go back to our mapping and then we can color it, aesthetic color equals cultivar, show legend equals true. So by adding this by cultivar, this matters a little bit more when we're working with a lot more data, but this is saying to essentially calculate plots individually for each cultivar. And then what this is saying right here, this aesthetic is saying, we're going to color our plot by the cultivar. So you can get really fancy with this, and you could do plots by cultivar and then color it with some other variable. So there's a lot of advanced tutorials online. If you Google Ggplot 2, there's like a data viz gallery on Rstudio where you can see figures that people have made that look really, really beautiful, and then the code that they use to generate it. So this is our Ggplot with the scatter plot and subset data. So run that again, and I'll zoom in on the plot and make this a little bit bigger so that you all can see. Okay, so now we can see when we look at the day of year. So this is just day 1 is January 1st and all the way through until the end of the year, 365, assuming this wasn't a leap year. And so this is the canopy height versus the day of year over time for these 3 cultivars. And it looks really sparse now that we have just 3 variables. So something that is worth thinking about when you're doing these sorts of visualizations is, would a scatter plot be the best way to represent this data? So another thing that we could do is we could do a line plot, and then we can use these points to show where our measurements were taken, and this will, the line plot will actually just do straight lines from point to point. So let's try modifying this to add some lines to it so we can see trends over time a little bit better, right? Because even though we have this time on the x-axis here, and this variable that we're interested in over time on the y-axis, it's kind of hard to tell what's going on right here, especially with this blue cultivar right here. At least with my bad glasses-ridden eyes. So let's try Ggplot with a line plot and scatter points to anchor the lines. So we can do this again. Data equals 6 figure data. Mapping equals the aesthetic, where x is equal to the day of year. Y is equal to canopy height. Say by cultivar. Oops. I need that to be inside of the aesthetic. Geometric point. I want line, and we'll run the line through the color. Mapping is equal to the aesthetic of the color, which is equal to the cultivar. I'll say that show legend equals true. And then we're going to, and this is a cool thing about Ggplot. What I'm about to show you is it produces everything as a layer. So if you remember at the beginning when I didn't give it a geometry argument, it just produced the grid based on the data. So every time you hit a plus, it's adding another layer. So the first layer in the Ggplot is going to be what grid the data appears on. It looks at the data, automatically adjusts the scale based on the data, which you can also manually tweak. There's a lot of documentation on how to do different aesthetic changes in Ggplot. It's very flexible. That's why I kind of called this making publication worthy figures. And so this first layer is the grid. The second layer in this plot will be the line plot. And then we're going to add a third layer where we put the points of the data line, or the points of the data onto the lines. And this should be a pretty cool plot at the end. And we'll make sure that the color is the same as the cultivar. If we didn't do that, it would just put black points. It defaults to black as the color of the plot. So by putting the mapping is equal to the color in the scatter plot that we're doing on top of the line graph, it'll make sure that the colors match in both layers. So we'll get a really cool looking plot at the end of this. And so now that I have run this, now we can see some of the weird trends in our data over time. And so this isn't the only way to visualize data. I'll leave it for you on your own time to look at some of the other geometric functions for Ggplot. There's some really cool statistically driven ways to visualize your data. You probably have seen them in some publications along the way. So this is a very, very popular software package for R for data visualization. And so now that we have this plot, see this weird trend, right? And so let's say that this now is a cultivar. That this is a strange behavior. And so let's take a look at how we can use some of the dplyr pipes to start to make summaries of our data. So say that plot looks weird. Sorghum shouldn't get shorter. What is going on? Did the grad students eat the sorghum? So we can take our figure data and we can find some summary statistics. So this is a little extension of dplyr. So we're going to say height mean summary is what we're going to store the variable as. We're going to say season 6 figure data and the pipe tab over because I just like everything in line. And we're going to say group by cultivar. Okay, and it doesn't like spaces after the pipes. So the spaces are important to not leave. And then I'm going to tell dplyr that I would like to summarize the mean height equal, this is a new variable that I'm creating. The mean height is equal to the mean of the canopy height. And so I'll walk you through this these and then statements or pipes. So we're saying to take our subset data and then group the data by cultivar. And then now that we have these groups by each cultivar, we want to find the mean height of all of these different cultivars across this experiment. And so we can run this. And then I can look at the variable height mean summary. And this will show us the mean value of each of the cultivars. And if we look at our plot, we'll see that the weird blue one right here is the one with the name 585961. So we'll go through here, 585961. Oh, that's really weird. The mean height is pretty inflated relative to everything else, despite this dip. And so we can keep building these different summaries in a bunch of different ways. So let's make this a little bit bigger. And so let's calculate this next little metric as standard error. So this is a common thing that you would calculate for data, and it's pretty easy to do in R. Let's calculate the standard error for measurements. So say height, SE, summary, and then season 6, figure data. Same thing, group by cultivar, pipe, say summarize. And then we'll do a little bit of math inside of here. And this is kind of like the question that Mandeep had in the break. So we can do, so standard error is the standard deviation, which the function for standard deviation in R is just SD. So do standard deviation of canopy height divided by the square root, or SQRT, and we'll say N, which the function N is the number of observations. So when a summary statistic like this doesn't exist, since R is a statistical programming language, and if you know what standard error is and how to calculate it, you can build up this sort of summary yourself by saying, okay, I can calculate standard deviation with SD and a variable, and then I have to divide by the square root of the number of observations. And so again, with the and then statements or pipes, is saying to take the season 6 figure data and then group it by the cultivar and then summarize it by calculating the standard error of the height, which is equal to the standard deviation divided by the square root of the number of observations. And so we can do that. And we have our new summary statistic. We can look at this, and the standard error is actually pretty much the same across all of our cultivars. Doesn't look too strange. And so what if we wanted to do this for, all of the different metrics. Say we wanted mean, standard deviation, and standard error in a table. We'll call that table height summary. So one way that we could do that, let's make a summary table of mean, standard deviation, and standard error. So now we can do the same thing, but we'll just call this height summary. And we're going to take our same data frame. This is 6-figure data. Do another pipe. And we'll do the group by cultivar, because remember, we want to summarize this all by cultivar. And then we'll summarize the mean height equal to the mean canopy height and then this is creating our new columns for our data frame. Standard deviation of height, SD, canopy height. And then we'll do the standard error height is equal to standard deviation, canopy height, divided by the square root of the n. Okay, and so now when we do this, we can say that we have a summary table for some of the basic statistics for our data. Print summary. So now we have this in a nice format. So you see this is a tibble. It's coming up as a tibble. That is a tidyverse thing, and it's equivalent to a data frame. Tibble is just a tidyverse way of doing it. There's a back end under the hood things that make them different from each other, but that's not super important. They're very, very similar. And it just so happens that the tidyverse ends up outputting a lot of things as tibbles. Okay, and so, but if we have this tibble, let's say we want a data frame. How would we do that? So Tyson introduced the as function. So we're going to convert our tibble to a data frame. I'm going to pause right here for a second. And I'll just let everybody give me a thumbs up if you have reached this. Apologies. I will shift the blame to myself. Okay. So I know I'm going through this a little quickly. The code from this will be available afterwards. And the video will be available afterwards. And this should be it's something that like just comes with practice too, you know, like this takes a bit of time to digest all of this information, and kind of one of the best things about a workshop is that you get exposed to a lot of information. One of the most difficult things, or things that I find to be hard, is to remember everything, because there's so much information coming. So it's really awesome that we have these videos and the code, and that's something that like I've never had with like an in-person workshop. So it's nice that we can all go back and look at this again, fast forward to the video to like this point if you're stuck. And if we save the script, can we go back to it in the output folder? I believe it will be in there. It just takes a little bit of time to write it out, but we're also going to save our plots. The last thing we're going to do today is we're going to save this summary table. We're going to save our plot, and we're going to save our script. And then we're going to run through how to use the I commands one last time as a group. And then we're going to move our data and our script to a folder on your own CyVerse data store account. So they'll be backed up on your own personal data store, as well as I'll push this to the workshop page when we're done as well. Okay. So last thing we'll do before we start writing these things out is we're going to convert this to a data frame. So there's the as function, so as character, as array, as numeric. There's one called as.data.frame, which allows us to convert tables or matrices to data frames. And we can do that with this height summary, which has our mean, our standard deviation, and our standard error. And so we can store that in height df summary. And then what we can do is we can write a CSV file and say X. So this is going to be your data frame name when you're writing this out. It'll be height data frame summary. And now the file name, which is going to go in double quotes, is going to be the path. So we're going to write this to we're just going to write this to our home in here. Or actually, I'll just follow along with what I wrote in the read the docs. My apologies. I will go to input / AG2PI workshop / ag data, and then I'll call this height summary.csv. And then what we want to do as well is say row names equals false. Otherwise, R will automatically write the row numbers and then it'll create this weird asymmetrical file that will be hard to use in the future. So I almost never write out row names. I almost never use row names. You might find a use for it. I've never found it in my research to be something that I've used frequently. I think maybe the only time I've ever used row names was with population ecology data sets, where it's like the sites are all the column names, and then like the species are all the row names. That's kind of the only time I've ever really used row names. But in this case, we don't want the row names because they don't have any meaning for what we're doing. Okay, and so now I just hit Command Enter on that write.csv. And we can look for this one of two ways. We can go to our files. We can go to the input, AG2PI workshop, ag data. See the height summary.csv. Or we can use our terminal. And we can go ls input AG2PI workshop ag data, and we can see that it's been written in there by using the stuff that we learned yesterday from the command line. So there's one more file. Right. Summary table. It's one more file that was, let's save the plot from before. So if we rerun, so let's call this figure 1. So you can store Ggplots as variables. Where we can do the day of year. Make this bigger. Y is equal to height. I cultivar. So I'm typing this out. You don't have to type this out. You can copy, if you've successfully made the line plot with the dots, you can just copy all of that code. I'm just typing this out one last time. Otherwise, this is nothing about this has changed. The only thing that's changed is that we're storing this as the variable figure 1. So we'll add the line, the mapping. Color is equal to the cultivar. We're going to add a legend. True. I'm going to add points. We're going to color those by cultivar. Okay, so this is exactly the same plot. Cultivar is stored as a variable. Okay, and so I'll run this. And now, normally a plot would pop up, but since I stored it as a variable, nothing popped up in the plots window. Would usually take over. And we can use a function called ggsave, export the plot as a PNG file. So we're going to use ggsave, and then this will be our variable name that we've assigned the plot to, which is figure 1. That is equal to the plot. And then you can see here that it's highlighting the syntax. So I kind of did this a little bit backwards. So we'll go file name. Equals, and then we'll go through here to input, AG2PI workshop, AG data, and then let's call this figure1.png. And so now, save this. We can write this out as a PNG file. Oh, object cultivar not found. So I misspelled it up here. So let's save this as figure 1 again and try writing this figure out. And let's go take a look at it. So it's zoomed in. So let's try running this and make this a little bit bigger. Let's take a look at the plot. We'll run this now that we know that this works. We'll run this. So right here it says saving a 1.04 by 1.193 or 1.93 PNG. So we can save this, and now that I've resized the plot window, you see how it's changed to these dimensions. So there are some other options for ggsave where you can specify the dimensions that you want to export. Yeah, so that, Mandeep, that means that your plot window is a bit bigger than mine. So it could be, it depends. I mean, usually you can like resize the figures. So if it's like a larger figure and then you make it smaller, the resolution kind of increases. But there are some options. If you look up with help with ggsave, there are some options for changing the different outputs. But I wanted to take maybe the last 10 minutes to run through this iRods to export these to your data store directory, but I'm unsure if we really have time for that. So I will walk you through the init and all of this. And I will do it relatively quickly, but feel free to go back and watch the video and you can go through this on how to move your folder or your files around. So I'll just quickly do the I commands init. So I'm in the terminal now. I'm no longer using R. And we'll do data.cyverse.org. And the port number is 1247. My username is rbartlemy. My zone is iPlant. And then my password is my password. I'm not going to tell you that. And now I can check. Remember the pwd command we learned yesterday. You can check and see where we are on iRods with ipwd. So you can see that I'm in my home directory. And I will now make a directory with mkdir. And I'm going to call it AG2PI checkout. And if I type ILS, which is equivalent to the list command, you can see I have a bunch of different folders in here, but this AG2PI checkout is now created. So if I do ipwd, I can see that I'm in my home folder. And I can do icd, AG2PI, checkout, do ILS. There's nothing in the checkout folder. Okay. So now I can see with pwd where I am on my computer. So I'm in home/RStudio. So the first thing I want to do is I saved my R script to my home directory in here. So I'm going to use iput ggplot exercise.r. And now, since I'm already in my directory with the icd, I'll see now that the ggplot exercise is in my folder. And I'll copy this over to the workshop community folder for everybody to see. And then let's say that I would like to back up my plots as well. So those are not in the same folder as this ggplot exercise R script. So I have to change it into input AG2PI workshop, ag data, and I can do ls, see what's in here. I can do pwd to check my working directory. Okay, I'm in ag data. And then I can do ipwd for the data store. So I can see that I'm in here. This is my computer. I'm in this folder, ag data. And on the CyVerse data store through iCommands, I am in this folder called AG2PI_checkout. So now I can do iput, I can do figure1.png, and it will move that figure that I made into the data store, which I can check with ILS. Okay, so that is there as well. And now I will check the CSV, make sure that that's here with ls. Okay, I have the height summary CSV. And so I can do iput height summary CSV. Enter, okay, and do ILS for listing on iCommands to see what's on the data store. And now I can see that in my folder that I made called AG2PI_checkout, I have now saved this ggplot exercise R script, the figure1 that we made, and then the CSV file. And then just to answer Mandeep's question in the chat, so the right CSV, we're going to have this, we have height summary, which we made from the functions. So that's the variable that we created from this subset data where we summarized it. We're going to convert that into a data frame right here, this as.dataframe. And then we're going to write the CSV out. This is all also documented in the read the docs page at the end, along with the I commands that I went through. So that brings us to the end of today's workshop. And I will post our feedback in the chat in 1 second. So please leave feedback on this afternoon, as well as if you haven't left feedback for this morning, you can just use the same form again and just check that it's Friday morning or Friday afternoon. And let me just stop sharing my screen. With that, I'd like to thank everybody for your patience and your time. I know 4 hours a day, 3 days this week on Zoom is a lot. Luckily, all of this will be recorded, so you can go back and look at it. And the read the docs page will be there as well as a reference. And so you feel free to reach out to us if there's anything that you find confusing, or if you would like next week for us to sit down one-on-one with you with something that didn't make sense. Just feel free to email me. I'll send a little summary at the end of today. I'll send a little summary email. And yeah, I think I'll stop the recording, and thanks everybody for your time. Thanks for sticking it out.